Hi, YouTube. My name is Nick. I'm a software engineer. Today, I want to talk to you about a thing that I made. It's called Llamaman. And what Llamaman does is essentially it is a LLM orchestration tool. It basically orchestrates multiple llama.cpp instances depending on what your deployment needs are. It's intended to bridge the linear, super simple deployments that you can do with Ollama, and it's intended also to give you more control over these deployments. It bridges the gap between Ollama and VLLM. Nobody did it, so I decided to do it. Why not? Initially, I wrote up an article about it, which you can find right here. So what is Llamaman? Let's take a look at the repository right over here. I don't have to, first of all, I don't have way too much time to work on this project because I have plenty of other shit going on. So without investing too much time, the best thing I could do is basically vibe code this with Flask. And Flask is essentially the only framework in Python that I am very close to. So for a local deployment and for something to, host a server, it is a pretty useful tool. Here are some of the features which I'm not going to focus in on at this moment. Instead, I'm just straight up going to show you what they are in practice. Also, there is this thing that I deployed literally the other day, and I posted to Docker Hub an image implementing TurboQuant, which is based off of the fork from the Tom Llama-CPP TurboQuant. But keep in mind that this thing is a bit behind because this is essentially managed by one dude. It's gonna lag behind slightly from the GGML Llama-CPP repository. So Llamaman is intended to fill in the gap between Ollama, and it also has an Ollama-compatible API as well. It's intended to fill in the gap between Ollama and VLLM. And it's also intended to run in Docker and easily manage multiple Llama CPP instances without having to go into CLI and manage scripts for the deployment of a new Llama CPP instance to swap out a model or whatever the hell. So I just wanted a UI that I can have control over and just manage that, just manage models that way. So without further ado, I'm straight up gonna go ahead and go look into a Docker Compose file that I have right here. The Llamaman container pulls from the repository the CUDA latest image. So Llamaman supports both database and file settings storage, meaning that your settings, whatever you do inside of the application, are going to be stored either in a database, which is it has MariaDB or MySQL support, or it's gonna save JSON files. So the JSON files will be set to a persistent volume that you need to define. In this case, this is what I'm using, and this is the internal directory where Llamaman will keep its data. Also, this is the models. Here, models are going to be downloaded and persisted through the integrated download manager in the app. And yes, I do know that Llama CPP has a downloader, but I wanted to implement a separate downloader because of the way that the app is essentially set up. And I'm going to show you what I mean in a second. This downloader also has limit modes. Per download, you can set per download throttle limit, and you can also set a global throttle limit. Then we have a logs directory, which is going to expand with time. So it's up to you if you want to persist these logs, depending on how many services it is that you manage. Then we have a target port. The app runs on port 5000 because Flask, but I've published it on 5005 because I have something else running. This is the Ollama port support. If you want the Ollama API, you can find it on this port, which is nice. And then we have the port instances for each Llama CPP server. So how this works is the app has the ability to manage multiple Llama CPP instances. For that to happen, each instance needs to have a port that it's running on. So we need a pool of ports and an external port that we can map it to, because Llamaman proxies incoming traffic. It can filter with internally set preset variables. For example, for temperature, for top K, top P, presence penalty, and maybe we can expand with further variables down the line. But for now, this is it. For now, since I'm going to be managing one instance for this particular deployment, I will be using just one ingress port, which will be published to external port 12,000 on my server, but this is how I've shown in the examples in the repository and the Docker Hub, which, by the way, I'm super proud of this. We have like 1K downloads. Damn nice. Apparently, other people like this thing too. But anyways, you can map a range of ports to this application, and that will be mapped internally to the app itself. Having this said, let's go ahead and take a look at something in the repository itself. So we have an external port range, and there is also an internal port range, which we can see here. This is configurable via environment variables, and this is what each Llama-CPP instance that's being proxied to by Llamaman is going to run on. I strongly encourage you to go ahead and take a look at the repository for the full setup and all the details on it. Okay, so let's go ahead and start this thing up. As I told you, I've set up a database for this thing. This is a purely demonstrational setup. Let's go ahead and just start this thing up. So I'm gonna do docker compose up -d. It's gonna start pulling. Unraid is blowing up right now. Okay, let's go ahead and start the instance. So this thing is gonna run on port 5005, and the first time you set it up, you're gonna have a page where it's gonna ask you to set up a username and a password, which is for the admin user. And of course, this thing, like everything else, needs to have an admin user, because especially in my case, because I have a cat and it likes to walk on the keyboard, but let's not focus on that. So let's go ahead and log in, and we are in the app. So let's take a look at what we're looking at and what we're dealing with here. So first of all, there's an indicator for your dedicated system resources, and right now I've dedicated a 4060 Ti to this deployment, which is at GPU 0. And in here, we have a model list for your downloaded models. Then we also have a downloads section where in here you will be able to see your downloads that are active. Now, if we go into settings, we have a bunch of stuff in here. So in settings, if we load, for example, let's load GPT-OSS 20B. For example, what we have here in this app, it's going to tell you automatically from the port ranges that we've set in our Docker Compose what external port it's going to map to based on what is free, based on how many instances you already have. Since we don't have any running instances yet, it's going to give us the first free port out of the bunch, which is port 8000. So then we have GPU layers, which will attempt to do an automatic calculation of how many layers of the model you can offload into your GPU. And in this case, if we set -1, it means that the entirety of the model's layers are going to be offloaded to GPU. So then an app will require you to set a context size for every deployment. Then we can assign CPU threads in case we want to, offload a model onto CPU. Just leave this at automatic. Don't enter anything unless you want something otherwise. So then we have parallel slots. This is an optional thing, but this is essentially how many conversations can your model handle at the same time. And what is important to note here is that there is a correlation between max concurrent and parallel slots. Parallel slots is provided by the Llama-CPP instance itself, and I usually leave it to default, because if you have one conversation with a context size of 22,000, which Llama-CPP will, by the way, override to the next closest value that it can. It's not going to be exactly this. But anyways, parallel slots is going to be essentially, if you have one conversation with a context size of 22,000, that's going to be your context size. But if you have two conversations that are running in the same time with this context size, that means that each conversation will be basically cut in half, and for each conversation you will have 11,000 tokens. I recommend just leaving this at auto unless you want something otherwise. So then we have the GPU devices, which you can specify. In this case, if we don't specify anything, it's just going to try to use all available GPUs. If you have more than one, it's going to be a list. GPU 1, GPU 2, and so on and so forth. So right now I have one, but I can also specify 0 for the identifier of this GPU. So idle timeout in minutes is basically essentially the same same feature that Ollama has. After a certain period of a model not being used, it's going to time out. So it's going to go into sleep mode, which is essentially shutting down the server, the Llama.cpp server, but it's going to keep its resources, meaning ports and a process ID for it. It's not going to hold anything big in memory. Just so next time you launch it, you have a free slot for that model already. Now, how is this managed? This is managed essentially, each Llama.cpp instance is launched via a semaphore, and a semaphore keeps track of that. For child processes, we have also background workers that are intended to manage zombie processes and pick up on old child processes. And if they can't be picked up, they're gonna straight up be killed. So yeah, kill all the orphans, I guess. So then we have max concurrent. This is related to the parallel slots, meaning that if we leave this to auto or 1 or whatever, with parallel slots being 1, we can have a max concurrent sessions of 3, but they're going to queue up to the 1 slot that the model can process. I hope that makes sense. So if we make this thing 3, it's going to be able to split this value into 3 for each conversation and process the 3 conversations. These are options that you kind of need to understand. If this is confusing to you, I encourage you, go ahead and take a look at the repository here. So then we have a max queue depth. So as I told you, each Llama.cpp instance is being proxied. So we can limit the maximum number of incoming requests with a queue. So we can, in this case, I've said 20 requests can queue up in a first in, first out principle to be handled as max concurrent requests, which will queue up in the parallel slots, either 1 by 1, or if this thing is 3 at a time, depending on how you want your model to run. So then we have an extra args section, which you can, specify extra arguments here. If you don't know what these arguments are, I strongly recommend that you go into the official ggml org llama.cpp repository and just take a look at the documentation and what is being supported. Then we have a few toggles here. So share queue with the same model essentially would mean that when you have 2 deployments, one running on port 8000 and one running on port 8001, in 2 GPT-OSS 20B instances on each of those ports, they are going to load balance this queue between each other. And they can have different settings for max concurrent, they can have different settings for parallel slots. Depends on what you want your deployment to be. And then we have an embedding model toggle. So about the embedding models, since embedding models are usually quite small. So for example, we have embedding Gemma is toggled to be marked as an embedding model. It adds an extra flag in the CLI options for the Llama.cpp server, which flags it as a model for embeddings. If you don't know what embeddings are, it's, basically vector calculations. You give it some information and the embedding model analyzes it with a prompt and gives you a vector. Also, another thing that marking a model as an embedding model will do, and this is extra functionality from the application itself, from Llamaman. So right here, we have an environment variable called Llamaman max models. What this will do is it limits the maximum number of standard models, standard meaning, for example, OSS or Quen, standard LLM models that you deploy, the big ones, not the embedding ones. How many models, standard models, can be loaded at a time? Why is this important? Well, embedding models can run purely on CPU. Here, I'm saying for this Gemma embedding model, you run only on CPU. And I'm giving it 4 cores. I'm giving it a context size, which is way too big, but it doesn't really matter. It's gonna take a port out of the pool, but it's not gonna match up to this Llamaman max models. Let's say that I launch GPT-OSS right now. We have a server starting. We can go ahead and view the logs real quick. And eventually when it's ready, it's gonna say that it's healthy. We're checking health status for the model. It's gonna say how many prompts are active based on our settings and how many are queued, and there's going to be a small graph right here, graphic, that will show you what the queue size is. So the model just went healthy. It's giving you the semaphore PIDs and all that. Yeah, all slots are idle. The server is running. You can also validate and check your settings being reflected in here. Let's go ahead and open WebUI actually. The Open WebUI auto detects that this is loaded, and the configuration for that is Llamaman for 2069, nice. Essentially running an equivalent matching up to the Ollama API for your Open WebUI deployments. So let's actually go ahead and load up, GPT OSS, and notice, because we're running Llama.cpp instead of Ollama, how much faster it is on a 4060 Ti. I'm not gonna load Ollama, but for me personally, it's straight up 2 times faster with Llama.cpp than it is on Ollama. I don't mean to shit on Ollama. They've made a really good, really successful product. Awesome. I just want control over my hardware. Plus, Ollama sometimes gives me kernel panics on my server, which I don't know why. It's that application specifically, nothing else does it. But anyways, so let's say hi to GPT OSS, and it returns a 53 tokens per second response when I'm not using Ollama. This number for me is in half when I'm using Ollama. It's close to 26, 27, maybe 30. I don't know what Ollama is doing, but Llama CPP works a lot better for me. I'll just leave it there. Let's make it implement a side by side markdown editor with live preview in Flask, HTML, and JS. And we're gonna let it think here for a second. It's already going, and now we see that the request is active. We can track the logs and all that. If I try to launch another model, like say for example, let's launch something small just for the sake of it, like Qwen 3.5 9BQ8. As you can see, it has its own preset, which I've already set for it. And it's going to tell us, you're about to launch an instance beyond Llamaman max models equals 1. Do you want to proceed? Now, only the admin UI can override this setting, meaning if I want to swap out a model from Open WebUI, I can do it in the same way that Ollama does it, but this model that's, for example, maybe working right now is going to have to be offloaded from memory. And there is also a priority setting relative to that. If we go into application right here and we enforce Llamaman max models for admin UI launches, this means that admin UI launches can go beyond the cap after a confirmation prompt instead of evicting the existing model. This will allow us from the admin UI specifically to launch more than one model. I hope this makes sense. But also we have the allow the Ollama API to evict admin launched models, and I just toggled this on. Let's toggle this off and let's copy the name of this model, okay? So now GPT OSS is loaded and healthy. Okay, sure, bro. So we go ahead and search for this model right here. We have the 9B right here. And let's actually go ahead and try to start a new conversation, and we just say hi. The API is going to respond 503 model limit reached. It cannot load a new instance of a Llama CPP server down here because the max models setting is 1. If we change that to 2, it's going to try to load an instance parallel to GPT OSS 20B. But if I go ahead in application settings and I do allow Ollama API to evict admin launched models, now let's look at what happens. Now it's going to start thinking. And what is it doing? It stopped the OSS GGUF instance, and now Open WebUI is launching the model that we requested. So this is very important to be mentioned here. Then we have cleanup settings. We have 3 workers available. Auto clean completed failed downloads from the queue right here. Auto clean stopped instances. This is the background worker that kills the orphans. Essentially, if the orphans cannot be adapted, we straight up kill them. There's a third worker where we remove stale instances records in case something crashes or whatever. By the way, here's something very important that happened. Because we have llama models equals 1, I've configured Open WebUI to use Qwen 2.5 0.5b instruct as a fast running model on CPU that will give us a conversation title. But because we have this thing equal to 1, in order for it to run the instruct model for the title generation, it will also evict the model which you specified that you want to chat with. So in this case, what I would particularly recommend to people in their setups, because I don't want one of these heavier models that think for a long time. I don't want them to forever have the queue filled up with trying to generate a 5-word title. That's completely impractical. So if you're gonna have like a similar setup to what I have right here, I recommend set this to 2, and then you launch your Qwen 2.5 with your admin account. Keep this disabled, because if you launch this with your admin account, Ollama is not going to be able to evict it on the LRU principle. And Ollama is going to be able to swap and launch instances at as many as it likes with whatever model you've chosen. I hope this makes sense. So then we have some download settings. We have auto retry failures. You can save your Hugging Face tokens. Those are being persisted in the database or the files. You can have API keys. You can disable the API key requirement and just make all other than the admin endpoints public and just use them freely. Right now we have, for an agent, for testing, for Open WebUI, Hermes, whatever, a bunch of API keys which you can manage. And yeah, I mean, this app is, I don't know, I kind of like it. I like how it turned out. And this is pretty much the entire thing that the app is for now. And I do have some plans for it in the future. By the way, this is the download page where you can select your Hugging Face token. And here you can just specify a particular GGUF to download from a repository, or you can just leave this blank and it will download the full repository. Yeah, I think that this app actually has come out to be quite functional. I'm not focusing on maintaining it like full time. I have a bunch of other stuff to take care of. I hope that you guys like it, and if you do, please subscribe, give the video a like, maybe share ideas in the comments what you think about it. I'm not the best at making videos yet, but I promise I'll give it a try to get better at this. And further down the line, there will be request logging for this app. I already have a prototype in place. I hope that you like Llamaman, which by the way stands for Llama Manager. Thanks very much for watching. Like the video. If you want to see more stuff like this, put down a comment, visit my website, whatever. And I hope that you subscribe so you can stay in touch with things that I put out there in the future. Live long and prosper. Peace.